Hello and welcome to MECLearn 360. In this video, I want to solve a problem with you to illustrate the concept of balancing of rotating masses. Alright, so let's read the problem together and solve it. A rotating shaft carries 4 radial masses. So the mass A is 8 kilograms. Mass B, we don't know, so we are denoting it by B. Mass C is 6 kilogram, mass D is 5 kilogram. Now we are saying that the mass centers are 30, 40, 40 and 50 mm respectively. So that is for A, B, C and D. Alright. Respectively from the axis of the shaft. Now we are saying that the axial distance between the planes of rotation of A and B is 400 mm, and that between B and C is 500 mm. Now the masses A and C are at right angles to each other. So find for a complete balance the angle of the masses B and D from A. That is the first part of the problem. The second part is the axial distance between the planes of rotation of C and D, and finally the magnitude of mass B. Alright, so that is the problem for us. So how do I solve this problem? Okay, so I'll start with first of all looking at the angular setting of the masses. So we were told that masses A and C are at right angles. What this means is that if I have mass A, let's say at the horizontal or making an angle of say 0, then mass C will be directly vertical to this one. So the angle here that we are expecting is actually 90 degrees to mass C. Alright, 90 degrees. Okay, so that is the information about the angles, but we were given planes of rotation. So let's try to get the diagram representing the planes of rotation. At this point, I want you to pause the video and see if you can get it. Alright, so there we are. We have the diagram representing the planes of rotation. So this first one right here represents the plane of rotation of A. This one is the plane of rotation of B. I have the plane of rotation of C, and finally the plane of rotation of D. Okay, this distance or this horizontal distance right here represents the axial distances along the shaft carrying the masses. From the problem, we said that the axial distance between planes of rotation of A and B is what? 400 mm. So that is 0.4 meters right here. And then also he said, and that between B and C is 500 mm. So that is B and C. This is what? 0.5. Okay. And then we were not given, in fact, we have been asked to find the axial distance between the planes of rotation of C and D. So let's call that X. And then this, in fact, these distances represent the center of mass. Alright, so the center of mass, and then we have 30 millimeters, 40 millimeters, 40 millimeters, and 50 millimeters. From the problem, we were given these values. Alright, so now having gotten these values, we need to come up with a table which will actually comprise of all what we have in this problem. So let's try to get the table right away. Alright, so there we are with the table right here. So the first column represents the planes of rotation. I have A, I have B, I have C, and then I have D. Okay, the mass at A was given as 8 kilograms. Alright, the mass at A was given as 8 kilograms. And then also the radius of rotation, which is also the same. So the R here is the radius of rotation, which is also the same as the mass center, or sometimes called the eccentricity, is 0.03. Okay, so MR is going to be the product of 8 and then 0.03. Let's pick our calculators. So let's pick our calculators and then find the value of 8 into 0.03. So I'm going to get 0.24. And this degree here means the angle we are looking at. Now, since the reference is going to be A, then we are assuming that A is actually on the positive x-axis, which is 0. Okay, so we want to do MR multiplied by cos theta. So MR was 0.24. So I'll multiply it by cosine 0. And since cos 0 is 1, it's going to be the same thing, which is 0.24 for this one. Similarly, I'll do 0.24. So I'll do 0.24 sine 0. In fact, sine 0 is 0, so I will get 0 here. Alright. Now this L here is actually looking at the reference plane. But first of all, let's fill the table and then we will come to the L. Okay. So the mass at B, we don't know. It was just B. But the radius is what? 0.04. That is the mass center. So if I multiply this by this, I'm going to get 0.04 multiplied by B. Okay. And the angle too, I don't know. So let's call this angle, say theta B. Alright. At this point, we can't do anything about this. So what we will do is we will just write here as 0.04 B cosine theta B. Alright. Similarly, 0.04 B sine of what? Theta B. Okay. For mass C, we know the mass is 6 kg, and this is also 0.04. And so if I multiply 6 by 0.04, so 6 by 0.04, I'm going to get 0.24 again. But this time around, he said C is 90. You know, with respect to A, C is making an angle of 90 degrees. Okay. So cos 90 is going to be 0. So we won't even waste our time doing this. And sin 90 is 1. So we'll get the same results here. Alright. These ones we know. And the mass at D. So the mass at D was 5. Okay. And then the radius is what? 0.05. 0.05, which is the same as the mass center or the eccentricity. 0.05 multiplied by 5, which is 0.25. Alright. But we were not given the angle as well. But we don't know the angle. Okay. So from here, we just do 0.25 cosine theta D, and then we will also do 0.25 sine theta D. Alright. So the question is, I have 3 unknowns. Alright, I have 3 unknowns, which is B. So I have 3 unknowns, B, theta B, and then theta D. These are the 3 unknowns as it stands now. But to be able to solve and get these unknowns, we have to take a certain reference plane and then take moments from there. And so the best choice is to find the ones with several unknowns. Looking at this clearly, comparing B and then D, clearly I can say that B is having several unknowns because I have B, I have theta B. Therefore, it will be best if I take the reference plane at B so that it will eliminate this B and then theta B. All right, so we have to take L from B. In other words, B should be our reference plane. So if B is our reference plane, then it means that every distance measured here is negative, and then every distance measured here is going to be positive. All right, so from here what we will do is that we will just start measuring the distances. So for instance, for mass A is going to be minus 0.4, that is to say walking from B to A, so minus 0.4. Since I am taking the distances from B, this part will be 0. With respect to C is going to be 0.5. all right, and then with respect to D is going to be 0.5 plus X. So maybe let's call that distance, say some let's say LD, where LD is what? 0.5 plus X. Okay, having done this, we will now take MR cos theta multiplied by L, and then take MR cos sin theta and multiply by L. So let's do that quickly. Let's do that. So I'll do 0.24, which is MR cos theta for the first mass, and multiply it by minus 0.4. So 0.24 multiplied by this, I'm going to get minus 0.096. Minus 0.096. All right. And then I will do MR sin theta multiplied by L. But MR sin theta is 0. So it means this part will be 0. Okay. So sometimes we want to do MRL. So if I do MRL, it's going to be MR, which is 0.24 multiplied by L, which is minus 0.4. Okay. And that is also going to be minus 0.096. Okay. Then let's take the second mass. You see, because L is 0, it has eliminated everything here. All right. And then let's take the third mass, mass C. So I'll do MR cos theta times L. But you know, MR cos theta is 0. It means that here is also going to be 0. But MR sin theta is what? 0.24. So I'll multiply 0.24 by 0.5. And let's do that. So 0.24 multiplied by 0.5. And that is going to be what? 0.12. Okay. So 0.12. And then finally, I want to do MRL. So it's going to be 0.24 and then multiply by 0.5. So that is going to be 0.24 multiplied by 0.5. I'll get 0.12. Okay. Having done this, finally let's look at this one. Okay. So I'm going to get MR. So look at this one. MR cos theta times L. This one I don't know. So it's going to be 0.25 LD cosine theta D. Similarly, the MR sin theta is going to be 0.25 LD sin theta D. And then MRL is going to be 0.25 LD. Good. So the table is completed, or the table we have right now is complete. Now, how do I solve for the unknowns? Okay, So the first thing to do is that you will first of all sum mr cos theta multiplied by L to be 0. In other words, this is what we are trying to say. So we are trying to say that mi ri cos theta I multiplied by Li should be 0. So we are summing all of them from the first mass to the fourth mass. And why are we doing this? You know, for equilibrium of a rigid body, summation of forces should be 0, and then summation of moments should be 0. Alright, so now this mr cos theta is moment, mr cos theta times L is moment, mr sin theta times L is also some form of moment. And then we will come here, and this is actually the forces. So let's do with these two columns, then we come here. So dealing with mr cos theta, clearly they are all zeros with the exception of only this one. So I can say that this plus 0.25 LD cosine theta d is 0. Okay, so from here I can say that 0.25 LD cosine theta d is equal to 0.096. Let's call this, say, some equation 1. Then secondly, I will say that summation mi ri sin theta I multiplied by Li should be 0. And I'm doing this summation for the first and then to the fourth mass. Okay, so let's go back to the table. So with that part too, I have only 0.12. Alright, so it means that 0.12 plus 0.25 LD sin theta d should be 0. That is when I sum everything in this column. So from here, I can clearly see that 0.25 LD sin theta d is going to be equal to minus 0.12. Let's call this equation 2. So I have two equations, two unknowns. I should be able to solve this. So how can I solve this? First of all, I'll say that equation 2 divided by equation 1. I have 0.25 LD, I have 0.25 LD, so it will cancel out. At the end of the day, I will get sin theta d divided by cosine theta d, which is the same as what? Tan theta d should be equal to what? Minus 0.12 divided by 0.096. So from here, I know. Alright, but before we do that, let's try to look at the quadrant. So looking at the quadrant, this is what will happen. This is the positive sin theta. This is positive cos theta. This one right here is minus cos theta. And this one right here is minus sin theta. So what this means is that the angle right here that we have is actually, so tan is opposite on adjacent. It means that the sine part is negative, and so it is here, but the cosine part is negative, positive. So the sine part is negative and it is here, and the cosine part is positive. So I have 0.096 and I have 0.12. So the angle that we want is this angle. And what is that? It's going to be the tan inverse. So it's going to be the tan inverse of 0.12 divided by 0.096. And what is that? Let's pick our calculators one more time. So tan inverse of 0.12 divided by 0.096. So I'm going to get 51.34. So 51.34 degrees. But that is not the angle I want. The angle that I want is the angle that it makes with the positive x-axis. And so that angle will be what? 360. So the theta that I want with respect to the positive x-axis is going to be what? 360 minus what I have here. So 360 minus 51.34. I'm going to get 308.66. And indeed, this is actually the angle that this is actually the correct angle, because looking at the equations we have. Having gotten this angle, then I can put it inside the first or the second equation to find my LD. Okay, so using the sine equation, I can say that 0.25 LD sine theta d, which I now know that it's what? 308.66 should be equal to what? Minus 0.12. So LD is going to be what? So LD is going to be minus 0.12 all divided by 0.25 sine what? 308.66. And then LD is going to be, so minus 0.12 divided by 0.25 sine 308.66. And what is that? So 0.6147. So let's say 0.61. Okay, let me write it. 0.6147. 6147 meters. But what is LD? Let's go back. We said that let LD represent this distance, which is 0.5 plus x. So it means that the LD that we want is nothing but 0.5 plus x. It means that if I want to solve for x, and then x is going to be what? 0.6147 minus 0.5. And that will be the axial distance between masses C and then D. So 0.6147 minus 0.5. And the answer I'm going to get is what? 0.1147 meters. So approximately 1147 millimeters. So that is the distance between the planes. All right. Now so it means we are done with some part of the problem. We are done with this part of the problem. So we are done with B. All right. So now let's find the angles and then the mass B. Let's find the angles. So theta D. We know theta D. All right. So theta D is now at 308.66. All right. So let's go back and then use the summation of the forces. So we are done with summation of moment. We want to look at summation of forces. So we would stand here and sum everything here to be 0. All right. But we realize that it is only 0.24, which is actually a number. All the rest are variables. So it means that if I stand here and write 0.24 and then I add it to, so let me go back and check. So 0.24 plus 0.04 b cos theta b plus 0.25 cos theta d. In other words, summing every column here. All right, so I'm going to get 0.24, and then I'm going to add it to 0.04 b cos theta b plus 0.25 cosine theta d is going to be 0. Now, looking at this here, I know theta d. I just saw for theta d. We said theta d is what? 308.66. All right. So it means that 0.24 b, 0.24 plus 0.04 b cosine theta b plus 0.25 cosine 308.66 should be equal to what? 0. Solving for this, I have 0.04b cosine theta b should be equal to what? Minus 0.24 minus 0.25 cosine 308.66. Now simplifying this further, then I'm going to get minus 0.24 minus 0.25 cosine 308.66. So that is going to give you minus 0.396. So minus 0.396. All right. Let's call this equation 3. Now I need another equation, and that will come from summation of, so this one I was supposed to do this summation mi ri cosine theta I from I equals 1 to n to equal to 0, and that is what gave me this. Now I want to do summation mi ri sine theta I should be equal to what? 0 from I equals 1 to the fourth. So this one is 4 to the fourth mass. Okay, so I'm going to get, so this is what I want to do right now. I want to look at this column and sum everything here. So I have 0.04b sine theta b, and then 0.25 sine theta d, and then 0.24. So let's add them. So in fact, it's going to be the same thing, just that this time around is going to be sine, which is 0.24 plus 0.04b sine theta b plus 0.25 sine theta d, but sine theta d is what? Theta d is 308.66. all right, this should be equal to 0. Okay, from here we can say that 0.04b sine theta b will be equal to what? Minus 0.25 sine 308.66 minus 0.24. What is that? So I'm going to get minus 0.25 sine 308.66 minus 0.24. And what is that? So I'm going to get minus 0.0447, or let's say minus 0.045. Okay, so now two equations, two unknowns. I will be able to solve for b and then sine, and b and theta b. All right, so I will divide equation 4 by equation 3. Since I have 0.04b here, 0.04b here, to cancel out sine theta b, and then sine theta cos theta b will give us tan theta b. All right, let me write it. So sine theta b divided by cosine theta b give us what? Minus 0.05 divided by what? Minus 0.396. Okay, so since sine and then cosine is negative, it means that if I draw the quadrant, it means that, so this is cos theta positive, this is minus cos theta, I have sine theta positive here, and then this one is going to be minus sine theta. Okay, so cos theta is negative, sine theta is also negative. It means that we will be here in this quadrant, and so the angle is this one, theta b. So if I want to look at the actual angle with respect to the positive x-axis, then I will add 180 to it. Okay, I'll add 180 to it. All right, so let's do this together. So theta b, in fact, theta b is going to be tan inverse of 0.045 divided by 0.396. And the angle that I will get, I will add 180 to it. All right, so let's do that. So tan inverse of 0.045 divided by 0.396. And what is that? 6.483. 6.483. But that is not the actual angle. The actual angle theta b is going to be, when I add, so 6.483 plus 180, and that is going to be 186.483. 186.483 degrees. So that is actually theta b. So in fact, we've been able to solve most part of the problem now. We need only b, and then we are done. And b will be the magnitude of the mass b. But having gotten theta b, let's take equation 4, 0.04b sine theta b. Now I know theta b as what? 186.483 should be equal to minus 0.045. What is that? So I'm going to get what? So what is going to be, what is b? B is going to be minus 0.045, and then I'll divide everything here by 0.04 sine 186.483. All right, and what is this then? So it's going to be minus 0.045 divided by 0.04, and then sine of what? 186.483. All right. So what is the answer? Oh, 9.964. So 9.964 kilogram. Ooh. So it means mass B is what? It means mass B that we want is 9.964. Right. So that is mass B here. So mass B is what? 9.964. The angle B, the angle of B from the positive x-axis is 186.483, and theta D, which is the angle of the mass D from the x-axis, is 308.66. The distance between planes C and D is what? 114.7 millimeters. All right, so we've been able to solve the problem. Thank you very much for watching.